I will make sure that the video is available after the session. So, whatever other people are doing with their videos, I'll make sure that they're on the LabVIEW wiki and available to everyone. So yeah, good afternoon, everyone. This is my session, my VI week session about the Raspberry Pi, sort of the LabVIEW Community Edition, the LINX Toolkit, and some work that I've been doing to, for the basically kind of enabling you to do some cool stuff with a Raspberry Pi and the newly announced LINX Toolkit. So I'm a LabVIEW champion, architect, do a bit of test stand every now and again, as well as being an embedded developer. I used to run my own NI Alliance partner, but as of sort of last month, I went back to working full time for Agilent. So that's kind of why, when you registered for the session, you'll have had like an Agilent logo at the top. It's just because that's who I'm working for now. So let's make a start then. So I just wanted to start off by, I think the Raspberry Pi is a pretty cool bit of kit, but I saw something on the news saw something on Twitter this week, or I think it was a couple of days ago, that I thought was quite amusing, which was somebody tweeted out that they've been running an IBM mainframe on a $5 Raspberry Pi Zero, on battery, running a bank's mainframe COBOL code. So I just thought that's kind of interesting of, the kind of things that you could do with a Raspberry Pi if you felt so inclined. But yeah, just for sort of a little bit of amusement, I thought I would share that with you all as it came out a couple of days ago. Okay, so let's move on to this guy. All right. Okay, so so my session is going to be about the Raspberry Pi and the LINX Toolkit. So one of the things that I wanted to share with you is something that like a little project that I worked on. So for NI Days back in November or October last year, I did this little example with the LINX Toolkit beta, which was basically a battery-powered Raspberry Pi robot that was, I called it the Democracy Bot. So basically it was a little remote control robot that you could control through a LabVIEW NXG WebVI, and the idea being that you kind of had to vote every 10 seconds which way you wanted the robot to go. All of the code for this and the 3D printed like chassis of the robot is all available. There's a GitHub repository, so if anyone feels like giving that a go. And okay, let me just remove my face. And yeah, so there's a a repository with the 3D printing files and also the code and stuff for that as well. So like the NXG WebVI and the LINX stuff. It is all in LabVIEW 2019, but I think it should be fairly straightforward to transfer that over. Okay, so to start with, I'm going to kind of go through how we set up a Raspberry Pi on the LINX Toolkit. So I'm going to do this as a live demo. So I'm going to start by switching over to this guy. Okay, so the first step to this then is to actually flash the like if we've got like a blank SD card, the first thing that we're going to need to do is put the Raspberry Pi image onto it. So one of the tools to use for that is called Etcher. And what we do here is basically we download the Raspberry Pi image from their website. So as we can see, I've downloaded Raspbian Buster. It's probably a little bit out of date now, but there's probably a more up-to-date version. And then in Etcher, we then specify that file. We go to select target, which will be our flash drive, our SD card, and then press flash. Now I'm going to save you having to sit through that because the process takes like 10 minutes or so. But basically, like that's all I've done on this SD card here. So this is kind kind of once it's finished, you'll then see a boot partition on the SD card. We can then open that up, and there's just a whole bunch of files and stuff in there. We don't really care about this, but it's good to see it, to have a so that you can see that it has actually transferred correctly. What we've then got, one of the sort of like hints and tips is that obviously like a lot of people will connect up their Raspberry Pi to a screen, and that's how they'll kind of set it up and that kind of stuff. Also, you might the Raspberry Pi's got built-in Wi-Fi, so you could plug it in via Ethernet, or you could try and set it up, you ideally want to have it on your kind of Wi-Fi network. Now, obviously, one of the issues with that is that how do you give it the Wi-Fi credentials? You kind of have to like log into it first, set it up on the Wi-Fi, and then be able to kind of connect to it. That way. Once you've got it on the Wi-Fi network, you can then kind of run it headlessly. But there is a very simple like trick that will basically allow you to communicate with the Raspberry Pi completely wirelessly and do basically all of the sort of initial setup that you need to do kind of without having to connect it to anything. So this is kind of useful for setting up like a remote installation, or if you don't have like a a wired network handy, then this is kind of makes this process a lot easier. So there are two things that we have to do for this to work. So number one is connect to our Wi-Fi network, and number two is enable SSH. So SSH is basically what we need to basically get into the Raspberry Pi console, and it's also what the LINX Toolkit uses for to basically to install the kind of like the LabVIEW LINX runtime, I guess, onto the Raspberry Pi. I've kind of preset these up here, but so basically the way that we do this is there's a couple of files that I've created that kind of allow both of these. So I'll show you this demo version of this file. So you basically create a file called wpa_supplicant.conf. And basically inside that file, you can give it an SSID, and you can give it your Wi-Fi key. Hence, I've blanked those out, and I have a different one that I'm going to put onto my SD card. But basically, this will pre-configure the connection to the Wi-Fi connection for you. So it's a really handy way of doing a sort of headless setup and making sure that it's kind of connected to the right network. And then the other thing that we need is basically just a file called ssh.txt. There is nothing inside the file. It just has to exist and be a file. I don't think it even has to have the .text extension. Like you can just put a file called SSH and then copy that onto your SD card, and that will kind of enable SSH remotely without having to go through the configuration. So I will copy these two files here, and all you need to do is just copy those into the boot partition on your SD card. So basically now when I put this into my Raspberry Pi, it will be pre-configured with my Wi-Fi network and also enables SSH, so that I should be able to remote into it. Fingers crossed. All right, so just bear with me a sec and I'll just take the SD card out of my laptop and pop it into my Raspberry Pi. And you can see my, hopefully, this guy. So the Raspberry. So as you can see, my plethora of hardware that I have here. So you can see my democracy bot up in the top left. 2, 3, 4, 5, 6 Raspberry Pis on my desk. I really need to stop collecting these things. But the one we're going to set up is the one over on the right-hand side. So this is a Raspberry Pi 4. This has got an automation hat on the top of it. So I'm just going to use this one as my, as my sort of guinea pig to show you how this all kind of works. So I'll take the SD card out of my laptop. I will plug it into the SD card slot on here, and then I will turn it on. So we'll just give that a minute to boot up. Now, obviously, with it appearing on your on your network, you will need to kind of find it. So the one thing that you will need to do is probably like what I do is I log into my router and I basically see when the Raspberry Pi appears and on my sort of list of connected devices, and then I can use that IP address for connecting to it. It does also have the host name Raspberry Pi, so you might just be able to so you might just be able to find it that way. Fortunately, what I've done, because I've got so many of them on my router, I've actually set up static IP addresses for them. No, nothing changing for the time being. Okay, I think I just cut out for a second there. Sorry. I think trying to log into my router has killed it, but fortunately the Wi-Fi is okay. So yeah, we can carry on. Sorry about that. Okay, so my IP address of my Raspberry Pi 4. This is the issue with using like home equipment, and rather than sort of and having so many things on there. Ubuntu OS, I'm not sure. I haven't tried it, so if I don't know if anyone else knows and can comment in there, but I think it's mostly Raspbian that it's designed to work with. Okay, so I can now log into this. We'll get a security warning, which we can just ignore. And you can see we've got the login screen for our Raspberry Pi. So the default username and password is Pi and Raspberry. And then we can log in and we can see that we've got the console. So one of the useful things that we can do now, I mean, we don't need to do any of this, but just to kind of show you around the Raspberry Pi, if you type sudo raspi-config, what this will do is basically give you like a configuration screen. So this allows you to change the password for your Raspberry Pi. You can set up network settings, boot options. So whether or not it should boot into a console. Michelle has said overclock. So yes, you can overclock your Raspberry Pi. And back. Languaging, interfacing. So the interfacing stuff here, you can enable and disable SSH, enable, disable VNC. So VNC, if I show you this quickly, this basically gives you a window into the desktop of your Raspberry Pi. So if you, this is, I think the one on the left of the Raspberry Pis that I've got. So it doesn't have a screen connected, but you can still enable the desktop, and then you can still log into it, and then you can treat it just like a a normal desktop, as if you had a screen on. So that's really handy for having a headless remote Raspberry Pi without a screen. Also told to mention that the Raspberry Pi 4 has two 4K, up to two 4K displays if you want to really kill it and overheat it. And then the other thing is, so if I now go back to my stop here, and then you've also got the ability to enable and disable SPI, I2C, serial, one-wire protocol, and GPIO. So I'm pretty sure that basically the I2C is now enabled by default, so you don't need to go in here and enable it, but I think we'll find out soon enough if that's the case or not. But yeah, so there's a bunch of options and stuff in here of sort of useful setup stuff, overclocking, advanced settings, expanding the file system. So obviously, like if you've got like a 4 gig image and a 32 gig memory stick, then this kind of automatic, you can use that option to kind of expand the storage space on your Raspberry Pi to fill the SD card. I think it's run by default now automatically as well. We can set up, the resolution, audio options, all this kind of good stuff. We can do an update. So yeah, that's just kind of show you some of the options and stuff in there. I'm not a Linux expert. I'm not particularly like au fait with all the Linux command line stuff. So I can't go into the full details of everything to do with it, but that's kind of like the most useful thing when you're first setting one up is to go into that configuration window. If you do have a desktop enabled, then you can go into if I click the right preferences, Raspberry Pi configuration. And this basically gives you the desktop version of the same thing. So you can set up whether it should boot to desktop or command line, set the resolution, all the same kind of options that we had before. In fact, yeah. So here we go. SPI enabled, I2C enabled. So yeah, that kind of covers that. So basically, like now that we've got our Raspberry Pi up and running, the next thing to do is to install the LINX Toolkit stuff onto it. So if I switch back to, LabVIEW, my virtual machine. Yeah, so this is just a virtual machine I've got running LabVIEW 2020 Community Edition. So this is obviously the new free version of LabVIEW. Yay, great stuff. And it includes the LINX Toolkit. So I think following a forum discussion a few days ago, I don't think the LINX Toolkit is available for LabVIEW 2020 like official yet, but yeah, basically like it's included in the community edition, but it will be available as like a an add-on that you can install to the LabVIEW 2020 professional and be able to use it in professional projects, that kind of thing. So the way that we kind of install the stuff on our Raspberry Pi is there's a LINX Maker Hub option in the tools menu. We go to LINX target configuration. Wait for this to load. And then all we need to do is put in our IP address of our Pi, press connect. Obviously, if you've changed the password, then you'll need to enter the correct password here. And yeah, we've seen there that it's connected. It's shown that we've got a Raspberry Pi, and it's kind of enabled the installation button. So we're onto a winner. Then all you need to do is go to installation and press upgrade. And then basically what this will do is run through a bunch of SSH commands on the Raspberry Pi. I think, in fact, if you click this option, you can see that it's doing some stuff. And this takes like a few minutes. So yeah, yeah. Just having a look at the Discord chat while that carries on. So yeah, the process doesn't take too long, but this is basically doing is it doesn't work on LabVIEW 2019. There is a beta version, but it's kind of the unstable version. It's going to be LabVIEW 2020 is the first version that this is kind of officially working and supported on. So yeah, while that's happening, yeah. So basically, what this is doing is it's kind of installing like it's a sort of mini version of the LabVIEW run, like real time or like the LabVIEW runtime onto the Raspberry Pi. And the way that this runs on the Raspberry Pi is it kind of runs in the background as a service. So we won't see LabVIEW running like on our on our VNC. It kind of runs in the background. So you should always think of it more as like a real-time target. It doesn't have a user interface by default, and it kind of runs in its own kind of I guess like like a container, it runs in its own sort of like boxed environment. So like if you run a command on the Raspberry Pi, it isn't sort of accessible outside of the sort of like the LabVIEW runtime. There are workarounds for that, so that you can kind of access the sort of the Raspberry Pi directly. But yeah, I haven't looked into that for a while, but there is some information out there as to how you can kind of run commands directly. Um, a question from Petter about debug working as on RT targets. Absolutely, yes. So I'll come on to that in a second and show you kind of how you can run code on there. Once the installation is complete, yeah, that's kind of it really. There's another sort of target info tab, and yeah, it shows you which version of the operating system is there, what target CPU you're running. You can configure the networks in here as well. And then, yeah, there's also, if you press the launch example button, um, and yeah, then here we go. So basically, yeah, if you press the launch example button, then what this will do is this will just create you a LabVIEW project, and we can see that our LabVIEW project has a Raspberry Pi target on it with the IP address from before, and then it will open up this handy little user interface. Which basically I think it just allows you to just toggle a one of the GPIO pins on the Raspberry Pi, and that's basically it. I think I can just run this. And you'll see, just like with another RT target, it will go through the deployment process. It takes a little while on the Raspberry Pi. It probably doesn't help that it's happening over Wi-Fi. But once you've done the first one, it's usually quite quick for subsequent. But yeah, as Peter was saying, so we can just run it as a VI. We don't have to kind of deploy it as a an RT executable, and we can toggle this in here. It's not actually going to do anything in this case, just because I don't have the same pins set up. But you can see that we can open the front panel. We can put a probe on there, and now we can see the live error status. So just like we would with RT targets, we can sort of probe around and see what's going on, just like we would with a fully fledged RT target. Obviously, like one of the main differences between this and an actual RT target is, it kind of behaves a bit more like a PC, and then sometimes a bit like an RT target. There's no like, a LabVIEW RT like platform has like deterministic timing and that kind of thing, whereas this is, there's no deterministic timing. There's no kind of, won't have like timed loops that run, at specific intervals and that kind of stuff. So if you're trying to do like time critical stuff, then the Raspberry Pi probably isn't for you. But for hobby stuff and for simple simple applications and that kind of stuff, this is a really good way to get going. So another question's just come in. Michelle said front panel events don't seem to work. So yeah, again, it's because it's kind of running as a service on the Raspberry Pi. Oh, sorry, Mike. It's running as a service on the Raspberry Pi. You don't have a user interface. The only user interface you have is basically by running it as a VI, like on RT. It's running on the Raspberry Pi, but you can kind of plug it remotely from your computer. So is there um, a real-time executable, and then you can then deploy that and run it as a startup executable. So I'll show you an example of that now. So if I so yeah, what I have running is if you look at the the screen, the the Raspberry Pi with the screen, we have the you can see there's a little sort of a user interface running on one of these Raspberry Pis. So if I switch over to the VNC view of that, this is basically like the blown up view of what's running on that Raspberry Pi. So this is running a startup executable, and what it's doing is it's actually reading. I have attached to the back of it. I have an analog input and output board. Hopefully you can see that, although it looks like my other camera is frozen. Okay. Sorry, just bear with me 1 second while I just sort this out. Okay, there we go. Sorry. I'm using a phone as the second camera, and unfortunately, the battery for one of them died. So I used mine, and I hadn't updated the stream. But hopefully now you can see, that I've just turned this guy around. And so here we have a Raspberry Pi with a screen, and there's on the back of it is like an analog, an ADC and DAC board. And what it has on there is it's got a like an LDR. For detecting changes in light, as well as there's a little potentiometer on here that I can change. So if I turn this around, you see as I put my hand over it, as it gets darker, as well as I can turn the dial on the back and adjust the the ADC voltage, and we can see that's pretty much running live as I adjust the dial. So this is sort of a startup executable on the Raspberry Pi. So if I switch over to my coding view, just show you what that looks like. So here we have my my main VI. So what this is doing is it is a very simple state machine. So we open up the Raspberry Pi, basically like the LINX, which is connection to the sort of Raspberry Pi hardware through the LINX Toolkit. So this is all tucked in under Maker Hub LINX. You have open and close, and then there's a bunch of library functions in here for doing I2C, SPI. If you've got like a BeagleBone that has analog inputs, I think, then you can read those from here. And yeah, so but the kind of bare minimum that we need is to kind of open with local I/O, which is local to our Raspberry Pi, and then a close at the end. And what this is doing is basically initializing a connection to the the hardware on the back of the Raspberry Pi, and then we have a simple state machine, which is basically just listening for a connection and then transmitting data over using my WebSockets library to an NXG web VI. So all it's doing is reading 4 of the ADC channels and then transmitting them as a JSON string to the NXG web VI. And if I show you the web VI, so this is using NXG4. Just because I didn't have time to update the sort of the community edition. So there is going to be a community edition of NXG. I'm not 100% sure if it's out yet. I'm sure someone will tell me if it is. LabVIEW NXG for free, as well as the web module, which is what you need to create web VIs, which is fantastic news because it means you can do things like this. Okay, Eli says it is out, so yeah, you can get an XG community edition as well, which will allow you to do just what I'm kind of showing here. And yeah, so all this is doing is initiating its connection to the Raspberry Pi, and then basically just reading the WebSockets data and then plotting it on a chart. So then there's a couple of kind of we have to do. So one is to get the the web VI to be hosted on the Raspberry Pi. So if I show you how I've done that. So once you've kind of created your web VI, you then obviously you need to build it. So you click here and press build. It's a little bit hidden, so I'll move this over here. You press build, and then this will create the web, create the output files, the web VI files that you need that you can host on, anything. What I then do, so there's two ways that you can host the web VI files. One is as a web service. So you can basically create a public content folder, and then this is the output of my web VI build process. And then you can basically create a LabVIEW web service, and you can deploy that onto the Raspberry Pi, and then it's kind of then hosted on the Raspberry Pi. This method is fine and works quite well. The only downside to it is configuring it is a little bit of a pain, I think, is how I'd describe it. As well as it kind of always has to have a subfolder. So if my IP address is 192.168.1.16, and then the web service port, you then have like /web service name as kind of the minimum. But for what I wanted to do here, I just wanted to have it hosted on the sort of top level of the Pi. So I'm actually using like the Apache web server, which I've configured on the Raspberry Pi, and there's instructions on how to do this on my blog post for my democracy bot, which is here. And I'll put that into the Discord and into here. And yeah, so there's instructions in here on how to kind of host it onto the the Raspberry Pi, and you can see basically if I turn off screen mode on here and show this guy, we can see here that I'm just accessing it via just localhost. There's no /, there's no nothing complicated about that. Just the files are just on the sort of the root directory of the Raspberry Pi. It just makes it a little bit easier to access rather than having to think about do I want what the web service address is going to be. So yeah, then this is my web VI running on here then. So the way that I then deploy that, so what I've done is actually I have it set up as a web service on here. Oh, hang on, switch back. I have it set up as a web service in my project, but what I'm actually doing is deploying the files to a public folder. So if I look in my destinations, I have this web root folder, which is basically a subfolder of the the default installation position. And then what the trick then is to basically tell the Apache web server that this folder, /home LabVIEW user natinst bin web root is the sort of the the top level directory for the Apache web server running on the Pi. So then every time I deploy my my VI, it's going to update the web VI files at the same time. I think there's probably like a neater way of doing this, like web services are a sort of slightly easier way. They don't need any sort of additional setup. But yeah, just kind of getting the files on there nice and easily and quickly. I think so you can kind of see the changes quite quickly as So once you've kind of got that set up, then you can basically create your RT executable. We can build it as we would normally with an RT VI. While that's happening, I'll just answer some questions. Do all the standard NI network communications protocols work with the Raspberry Pi streams, network shared variables, etc.? I don't know. I have a feeling that network streams will work. I think connecting to a network shared variable, maybe not. So yeah, I don't know if anyone else has any more experience of this than I do, but yeah, I've tried TCP/IP, and obviously the LINX toolkit has functions for doing sort of hardware communication, but I haven't aside from like web clients, like talking to web services, like HTTP client VIs I've tried. and also like WebSockets. So anything that's based on like TCP/IP, pretty much works. That's how this is working. Eli says he believes the answer is yes, so they should work. Um, um, and have you tried Qt for a GUI? No, I haven't. I was kind of like, obviously there are lots of ways of producing like user interfaces on a Raspberry Pi. So I didn't really want to go into, all of the possible techniques for doing that. I kind of wanted to just stay within the LabVIEW world for my user interface, just because I think it makes it easier and simpler for I think it makes it simpler and easier for people to that come from a LabVIEW experience to try again. From LabVIEW experience to get started with this. Okay, so my RT executable is built. I can then do run as startup, just like we would with an RT target. And this will load the code onto the Raspberry Pi and kind of settle it to run on startup. And one of the advantages of the fact that LabVIEW runs as a service basically means that we don't actually have to restart the entire Raspberry Pi. It just restarts the service part and leaves your Raspberry Pi still running. So if I switch over to this guy. So see, this is my, the Raspberry Pi that I'm deploying to. If I click OK on here, the deployment finishes. You can see it stopped running on the Raspberry Pi. It's now asking me to reboot, so I'll press yes. And this isn't going to reboot the whole Raspberry Pi. This is just rebooting the LabVIEW runtime part of it. The sort of the container, I guess. I don't know if there's a technical term for it, but yeah, it kind of runs in its own kind of container. It's got its own kind of like root folder and that kind of stuff when you look at it on the Raspberry Pi itself. But I guess the takeaway from that is to just be aware that if you're writing to a file path in your VIs on the Raspberry Pi, they're not going to be in the same place when you access them on your Raspberry Pi, because there's a kind of a folder hierarchy that's kind of where the LabVIEW stuff starts versus where the Raspberry Pi stuff is. Few comments from people. So yep, and so we can see now that my web VI has started up again. So without having to reboot the entire Pi, you can kind of close things down and open them up again. Okay, I'll go to a few questions. So it seems like network published variables work. TCP and all are all available. WebSockets is good. Shared variable engine is not available. Seems to be the summary from that. And obviously no front panel capabilities because it's kind of running in a service. You kind of have to use something else for your user interface if you want to run the user interface on the Raspberry Pi. Of course, what you can do is you can you could, just like you would with like an RT target, where you have a part that runs on the target, and then you have another part that runs, a LabVIEW host application that runs on a normal PC, and you communicate between the two using TCP/IP or network streams. There's nothing to stop you from doing that either, I don't think. Eli suggested using system link tags if you want to avoid complexities of hosting the web VI locally. So so obviously like all the system link functions should work as well. So if you've got a web VI, you can have Raspberry Pi pushing stuff up to system link, and then access it from other places. Does that mean you cannot access root files on the Raspberry Pi from LabVIEW? Not directly. It is possible, but it needs a bit of like a hack to basically like kind of break out of the service and be able to communicate with the sort of the Raspberry Pi file system directly. You kind of have to I think it's like you initiate an SSH from within the Raspberry Pi to the Raspberry Pi, or sorry, within LabVIEW, the LabVIEW sort of service to the main Raspberry Pi, and you can then execute shell commands through that, which would then allow you to, copy files and that kind of stuff. But yeah, it's not something that I've played with too much. But yeah, there's I think on the Maker Hub forums there is yeah, some information about yeah, how that all works. Sebastian has asked, is the 26% reading in the upper left the CPU usage? Yes, it is. Yep. And the temperature as well. So you can see it's pretty warm in here. Yeah, just in case you hadn't seen that. The final thing that I was going to show on this, so obviously this has got a graph in it. What I found was that the built-in the Chromium browser on the Raspberry Pi won't display WebVI graphs. So the people from NI that are listening, yeah, I found that I had to use Firefox to get it to display the yeah, the chart. Showing just text and normal stuff is yeah, is fairly straightforward. But yeah, yeah, to have the graph display, you have to use like Firefox on the Pi, just in case anyone else falls into that. But I'll just kind of demonstrate that. It comes up with a whole bunch of errors and stuff. Eli's asked, do you know a way to execute terminal commands from LabVIEW? So yeah, I think you can just do system exec, right? So in fact, so I'll show this first. So yeah, here we have the same web address. And yeah, it just shows a blank chart and it doesn't connect. And there's a whole bunch of like JavaScript errors and stuff that are going on in the background. So yeah, it kind of yeah, isn't too happy about that. Okay, so I think that kind of shows the sort of end-to-end kind of like workflow of how all this stuff kind of works. Just Eli reckons that might be fixed in version 5. The issue with it not working in Chromium. But basically just look up, how to install Firefox on Raspberry Pi. It's called like Firefox ESR for reasons I don't understand. But yeah, that's kind of got the, you can just install it through a shell command and run that. Okay, so now on to the I guess the final part of this. So one of the things that I've been working on kind of since the beta release of LabVIEW 2020 and some of the 2019 stuff is I've been working on kind of creating some like libraries that you can use to basically to get up and running with the Raspberry Pi and LabVIEW quickly. So basically, like what I've done is created a whole bunch of a VI package, and we can see that. Where's it gone? Yeah, I've got a GitHub repository which is called like Media Mongrels Limited RPi LINX add-ons, and what this is it's basically a collection of libraries for communicating with sensors and hardware and various hats. Yeah, using the Raspberry Pi with LabVIEW. So source repository, anyone is free to contribute to it, or if you want to fork it and break it or do stuff to it, use it for your own purposes, that's absolutely fine. And there's a whole bunch of support for some of the sort of like more widely used hats and sensors and things like that for the Raspberry Pi. So the only real sort of like project that I've done with the Raspberry Pi so far has been like my democracy bot, but I'm hoping that kind of by putting all this stuff out there, it's kind of empowering you and getting you go out and create your own creative projects using the Raspberry Pi and the LINX Toolkit. I'm just trying to sort of help do my little bit to help remove the sort of barrier for entry of we can plug in some hardware and get up and running with it. So yeah, so I'll kind of show you a few examples. So if I show you the stuff that I've got on my desk. So there's a couple of Raspberry Pi Zeros. Unfortunately, these aren't supported by the LINX Toolkit. I would really like it to be. I believe I'm hoping Eli is still here and is going to put a comment on this, but yeah, I think a really compact target like that is a really cool thing that we could add some sensors and a battery to, and use as a sort of little remote data logger thing. I think would be really cool. So yeah, we can't really use these two, but there's also we've got here that we just set up running an automation hat. I've got a Raspberry Pi 3 with a Sense hat. So the Sense hat is the one that's used on the Astro Pi project, which is where they basically sent a bunch of Raspberry Pis up into space with a big handheld keypad thing. And so there's a whole bunch of sensors and stuff on there. We've got like a grid of LEDs. There's a little joystick. There's a temperature, humidity, pressure. There's a 9-axis IMU, so we've got a 3-axis accelerometer, gyroscope, and magnetometer on there. And then the last one is an Explorer Hat Pro. So this is basically sort of a more of a prototype one. So we've got a bunch of capacitive touch buttons on here. There's a bit of breadboarding space, and then kind of just to show you the sort of prototyping stuff that we've got on here. It's basically I've got some extra sensors on here. So there's another analog to digital converter. I've got like a little temperature and humidity sensor, as well as a lightning sensor, which is what you can just hopefully see at the top if my camera decides to focus. We don't get a lot of lightning, but I thought it'd be a fun project to try and a fun sensor to try and incorporate into a measurement, into a weather monitoring station, for example. So pretty much some of the sensors on the Explorer hat I haven't completed the integration for, but the hats themselves, pretty much everything is working in terms of how far I've got so far with the libraries. So just post the link to the Discord in the session chat, just so someone's asked for it. Just go through a few questions. So yes, there is a GitHub for my other projects. So the NXG, like the democracy bot code, is all on GitHub. The code for like my simple NXG example is on there. So if you just have a look at the the Media Mongrels Limited repository, then yeah, there's a few things on there. We've also got so the Pi Zero runs an older CPU with an older instruction set that LabVIEW RT isn't compiled for. For a zero form factor, check out the Banana Pi M20, but it costs more, but it's comparable in specs to a Pi 3. So does that work out of the box then, Derek, with the LINX Toolkit? Earliest Raspberry Pi version that it can be used on, I think the 2B Plus, I think, is the earliest one. So it works with the 4, 3, and B Plus, I believe. They've run Raspbian on the Banana Pi, still waiting on mine to arrive from China to confirm. Okay, fair enough. Cool. Okay, so yeah, I'll just show you some of the examples then from this. So the example that I showed with the analog to digital converter, that is included in my library. So this supports an ADS 1256 analog to digital converter, which is it's part of a wave shield, which is what you can see on the back here. So this has got, I hold that up, hopefully you can see it. Just plugs into the back of the Pi. It's got some screw terminals. Some of the analog inputs outputs are sort of wired back into itself. And there's 2 DAC channels, and I believe 8 single-ended or 4 differential analog input channels on there. And I think it's like a 24-bit ADC as well. So it's quite a high precision for yeah. Sorry, excuse me. So yeah, this is the a library for the for that particular board. So there's you can control the DACs, you can read the analog inputs. I will show you for my sense hat. So just to show you through the library. So when you install the VI package, you get a Media Mongrels library in here. And inside here, you can basically see all of the individual hardware and drivers that are supported by the library. So there's support for analog to digital converters like the ADS1256 and the ADS like 1015 and 1115 are both supported as sort of low cost. And they're the kind of things that you can buy if I can find them in my drawer. You can just buy these as like a sort of prototyping. Oh, get this open. So from sort of your local electronics hobby store. We used to have Maplins, but they were pretty useless anyway. And then so this has basically got analog inputs on it. So you can use these. They're like £5 each or something, and you can order them online and use them in your project with the Raspberry Pi stuff. There's also support for the some of these libraries here are for for things that are used on some of the other hats. So, capacitive touch sensor, HTS 221 is a temperature and humidity sensor. LPS barometric pressure sensor. So we've got temperature, humidity, and then conversion into altitude. Yes, altitude. 9 degree of freedom IMU. So 3-axis accelerometer, gyro, magnetometer, which is used on the Sense hat. SN3218, which is a PWM LED driver board. DAC 8552, which is the one that's used on on the Waveshare high precision ADC DAC board. The PCA 9685, which is a 16-channel PWM servo board. So that's this one that you can see here, and the one that I used on my Raspberry on my Democracy bot. So I was using that to drive the servos. And then we have support for some of the hats. So the Sense hat, Automation hat, and the Explorer hat Pro. And each one comes with, each of these has got some form of example. So if I open up the Automation hat example, which is, I didn't mean to drop it down. You can see it comes with an example here that allows us to, I'm really hoping this will just run. Are there any limitations on what pins you can assign to DI or DO using LINX? I've had problems with some hats that use I2C SPI lines to DO. I'm not sure. I think if you I've got an error. Okay, maybe I2C is not enabled on my Raspberry Pi. Okay, so what I'm just doing, just to show you as I'm working through this, I'm just going to check whether or not I2C is enabled. So you go in here, would you like I2C to be enabled? Press enter, it is enabled. And hopefully after a sudo reboot, and we'll just wait for that to load up for a second, and I'll just answer a few questions quickly. Good tutorial. Okay, LINX restricts you from using pins available as I2C or SPI. So if they're, you can only use the sort of GPIO pins. There is a list on the Maker Hub forum somewhere of which pins you can use, I believe, and like the pinouts that tells you what they can be used for. Unfortunately, Jay, I don't have any sort of examples for sort of student teaching in terms of showing waveforms or that kind of thing. If I had more time, I'd have maybe set up my virtual bench with the the Pi to show some cleverer signal measurements and that kind of thing. But yeah, I just didn't have time. But obviously with a an ADC, you should be able to feed an output from a generator, as long as you're being careful of the voltage levels. Okay, let's see if this will run again now. There is a custom I/O configuration options available that I haven't looked into. Just noticed it last night. Might be a route to look into. So that might allow you to do custom configurations. Okay, this is running again. One of the things that is really cool, which I'll just show you while this is loading up. So one of the things, if you're doing stuff with a lot of the sensors that I've added support for are I2C sensors. So something that I found really useful to make sure that your sensors are hooked up and communicating properly is this function, which is sudo I2C detect -y1. And what this will do is this will tell you all of the I2C sensors and their addresses. Well, not the sensors, but it'll tell you which I2C addresses are in use. So you can see this is my this guy, the Explorer Hat Pro. So we can see that we've got I2C devices on address 3, 28, 48, 49, and 76. So that's really useful for debugging if you're not sure which address. Some devices have configurable addresses by toggling lines or connecting them high or low. You can then basically use this for figuring out figuring out what's what. So if I now switch over to this, I assure you that I haven't done any magic or jiggery pokery to make this work. Hang on, there we go. In the background, but we can see now that this is just running my sense hat example. If I hold it up and so you can actually see it. We can see that it's flashing the lights, and I've got controls on the front panel to turn the other lights on and off. The Sense hat has something that's quite cool, which is you can, or the sort of the, I guess the Arduino or Python library has this, and I kind of thought it was quite a cool feature, which basically means that you can automatically control the LEDs based on, when I toggle the outputs, this is actually also toggling the LEDs. So you can see, just like you would with, an industrial control system, you might have indicator LEDs to show whether or not things are, enabled or, on or off. We can do that. That's part, built into this library. And so, we can toggle the, relays on and off and all that kind of stuff. And then, we can see there's an ADC on there, which is 0 to 24 volt tolerant. And so, it's reading about 5 volts. I've just connected it to the 5 volt line. So, that's one example of one of the hats that I've supported. The sort of the programming interface for it, I've tried to make as simple as possible. Basically, once you've kind of opened up your LINX session, then there's just like an open automation hat function, and then all we're doing is going into a loop where we're just reading the inputs, setting the outputs, reading the ADC, and setting the LEDs, and all the sort of the complication of how that works is all kind of abstracted away, allowing you to get started with it, nice and quickly. If people are willing to hang around for a little bit longer, then I'll just show you the Sense hat, which is this one. So this one has got the Sense hat hooked up to it, which open up the Sense hat example. This. Yeah, and then here we go. So, just pretty much straight out of the box, this is yeah, it is working. There's a few bugs like the setting the LEDs doesn't quite work properly that I haven't had time to investigate. But yeah, we can see that we're interacting with it. Pressing the little joystick we can see is toggling the buttons on there. And yeah, you can see it's quite warm in here, but I think a lot of that is just because it's sat directly above the Pi, so it's more the heat from the CPU, which is kind of directly underneath it. But yeah, we've also got the accelerometer and stuff on there as well, so we can see that those values are updating. Okay, that was kind of all I had to show you. If people want to stay on and ask questions, then I'm happy to carry on for a bit. If there's anything else you want to see or ask, then that's absolutely fine. But yeah, that was kind of the summary of my of what I wanted to show you guys. So yeah, there's a GitHub repository which has this in, and then there's a version 1 of the VI package, which you can just grab that from here, install it, and then you've got all the examples and all the libraries and stuff for that. I am gonna continue working on it. So these sensors that I've got on here, I'm gonna add those in. So there's a few sort of more options and things. There's a few bugs in there, just from trying to get all this stuff in. But yeah, other than that, I was gonna stop there. Hopefully you've all found that interesting. Hopefully learned something new. If anyone does want to contact me, oh, okay, yeah. So there was a question about like ADC DAC rates and that kind of stuff. I haven't really played around with it that much. So like in the library, I know that I'm not doing things in the most efficient way. In terms of like, I'm mostly doing like single shot acquisitions. I haven't tried, to get the sort of continuous acquisitions working for all of the different module types and things. So yeah, you know, I kind of, feel free to like fork the library, and if you can get it going faster, up to 30 kilosamples a second, then that's then please submit that to the library. But it doesn't really obviously there's no sort of deterministic timing with the Raspberry Pi. There's lots of other things going on, if you're running a GUI and all that kind of stuff. So I'm not sure like how fast you can do like the I2C bus communications and that kind of thing. I haven't tried to optimize it for performance. It was just to show the sort of low level the so you can kind of get going with reading some data in, triggering some relays, that kind of stuff. Questions. Yeah, so the Discord link, let me see if I can find that. Okay, I'll put the link to the Discord in there, which is what we've been using for the VI week sessions. So I think if you click that, it should take you straight there. Otherwise, Derek has set up a fantastic little portal, VI week, which I'll also put in here, which is how you can find out about all of the other sessions and things in there as well. Few more questions. Is there a way to install native Pi code as part of a deployment and then execute locally on the Pi? I haven't tried it, but probably yes. Yeah, I don't see that there's, obviously you can just add any extra files that you want to your Raspberry Pi deployment. So, if you have like a Raspberry Pi library or something that you want to install onto the Pi, I don't see that would be a problem. If you want to call other functions. yeah, and like I said, it is possible to communicate from the sort of the LabVIEW service out into the like the regular Raspberry Pi environment. But yeah, I just don't have the information on that. If I find it, or if someone yeah, I'm sure someone will post it into the Discord server. Francis, please have a look on the link, the VI week link. I'm sure there'll be a link to the wiki on there, which will have the, I'll make sure that the recording goes up there. Question about DIDO specs. I need minus 10 volt, 10 volt AI and AO at the same range. The hats that I have here don't. The automation hat is, I think, 0 to 24 volt input. Hang on. So yeah, this guy is 0 to 24 volt ADC, and like DI tolerant inputs and outputs. But most stuff, like most of the ADCs on the other hats, are 5 volts. But if you're driving you have to be really careful with the Raspberry Pi. The DI-DO is 3.3 volts. So obviously, if you put anything above that onto the Raspberry Pi, you're risking damaging GPIO pins. Okay. Yeah, I mean, obviously, like if you are looking for other ranges of analog inputs, analog outputs, there's nothing to stop you from sort of prototyping your own thing. So if you wanted to, if you found an ADC chip that supported that, then adding the support for is fairly straightforward. What I've done as part of my library is wrapped up. If I open up one of these guys. So most of the chips that are used on the hats are I2C, and what I've kind of done is wrapped up the low-level I2C communications into its own kind of wrapper, just to make things a bit easier. It kind of hides all the LINX stuff away, and there's a few sort of useful utility functions in there when you're doing like I2C communications. So there's things for like reading registers, 16-bit registers, reading bytes, writing bytes. Often, if a lot of the I2C devices support auto address increment, which means once you read one register, it then increments the address register, so you can read a whole bunch of addresses in series. And to do that, you have to kind of make the MSB of the address one. So there's a little utility function here which kind of does that for you. So yeah, I've tried to make it easy for people to add their own sensors and kind of grow the library. And if you don't want to use like the sort of higher level libraries, then you can always just use like the low level I2C stuff. Which is there's plenty of examples of how to do that in here. Okay. Trying to duplicate an SP-RIO setup to control a spectrometer. Yeah, so one of the back when the LINX Toolkit first came out for LabVIEW 2014, I'd done a library I'd done a project for monitoring my narrowboat. So it was a single board RIO, connected to a GPS, hooked up to the communications for like the power network and the power monitoring, battery monitor, that kind of stuff. And I was able to take that application, just remove the one part that did some analog input, and then compile and run it on a Raspberry Pi. And I had like WebSockets based web dashboards and that kind of stuff, and it all kind of transferred straight over from the single board RIO onto the onto the Raspberry Pi. So you can do serial comms using VESA, network stuff. It's there's a lot of really cool stuff you can do. If you have if you want to add like serial ports, like a lot of the FTDI USB to serial converters. They work with the Raspberry Pi as well, and you can then communicate with them over VESA. So that's another really easy way of adding additional hardware and sensors. I've got this little where's it gone? This GPS sensor here, which is the one that I used on my sort of boat monitoring system. And in my drawer of goodies, there's also things like this, if I can get it to go into shot. So this is like a GSM, GPRS, and I think GPS module which fits onto the Raspberry Pi header. So again, so you can quite easily then connect a Raspberry Pi up to the internet or to the world, or for sort of GPS tracking and all that kind of stuff. I think we're pretty much there with the questions now, so I'll probably come to an end. Does SSL now work on web service? You've led excellently into segued perfectly into my session on Thursday. So I'm not sure about if it works on the Raspberry Pi, but I'm giving a session at the same time on Thursday to talk about the new TLS and SSL functions that have been added in LabVIEW 2020. It'd be a bit sort of more informal because but hopefully you should be able to learn sort of the basics of how to use the new functions, how to do secure communications in LabVIEW 2020, how to secure TCP/IP, and a little bit about the sort of enhancement to the WebSockets library that I created to do secure WebSockets communications as well. So tune into that session on Thursday if you're interested in hearing about SSL and TLS stuff. Okay. Hopefully you'll all stay around, have a quick break, and then come back for Derek's session. He's going to be talking about some robotic stuff for also using the LINX Toolkit. So I'm hopefully going to stay and listen into that. Thanks everyone for coming along. Hope that was interesting. Feel free to reach out to me through the Discord. And the recording should be available soon. All right, thanks a lot. Bye-bye.